Hey, welcome back. Today I'm going to do something a little different. I'm going to do some teardowns. Now, before I kind of shied away from doing some teardowns because, you know, I'm really not the expert to be talking about how to engineer a piece of equipment or design a circuit. But I find teardowns interesting in the fact that it really showcases how the people designing the piece of equipment, where their heads were at and what they were thinking. And obviously there's other people on the YouTube that do better teardowns than I would ever do, but I just thought this was interesting in the sense that this last summer I purchased a IBM server, and I'm not talking about blade servers, I'm talking about a real high horsepower server. And this thing was, oh, what is it, 7 feet tall. The cabinet itself, I'm talking, 7 feet tall. It was over 4 feet deep because it barely fit on the trailer, and it was just about 3 feet wide. And that thing was packed full of server components and accessories and modules. And you know, I purchased it as a whole. So anyways, I have a mountain of equipment here, components, modules. And I thought it would be cool to go through some of this and open it up and show you guys exactly what's inside. I find looking at this stuff fascinating, and how it's been designed and put together, and the quality of the work that they did to assemble it, and the components they used. And here's a first piece I'm going to look at. This is actually just a fan controller. And all it does is it controls one fan. And let's look at the plate here and read the specs. So it's this thing's made in Slovakia, manufactured Delta Energy Systems of Germany, made in Slovakia for IBM Corporation. So this is you know, they roll their own on these. So it has an input of 350 volts DC, 5.5 amps. Output is 235 volts AC, 4.1 amps at 3-phase. So what it is, it takes DC voltage in from the main power supply and converts it into a 3-phase power for running the fan. Now, I think I've already scrapped the fans from this server. There was 4 giant fans, and I pulled them apart and salvaged the copper out of them. They weren't that big, actually. The motors in these fans were probably the size of my fist. And, you know, they were squirrel cage fans, and they're 10-inch in diameter. I should actually go grab one right now and show you. Alright, so I just went through my scrap bin and looked for evidence of those fans that I was talking about, and I couldn't find any because they were already gone for scrap. But here's one of the armatures out of one of the fan motors. And like I said, it's, you know, it's about the size of my fist. I already harvested the copper off of this. And this is the armature. This is a stator. And the fan has magnets, and it rotates. So here's an example of a smaller fan. You know, like this one's probably a quarter of the size of the other one, that the main fan, the one that powers or cools the processors. This is an auxiliary fan, and let's read the specs on this one. This one's 235 volts, RMS, 3-phase, 0.695 amps maximum, and draws a maximum 175 watts, and runs at 4,300 RPM. So these are very powerful fans. You know, they're fast, they're loud, they're noisy, they consume a lot of energy, but they're built to move a lot of air. This fan alone probably, you know, it sounds like a turbine when it's running. But this one here, this one is imagine it scaled up by 4 times. The fan itself was probably this big, and there was 4 of these fans that cooled the 8 slots for the processor. I'll get to that later. I'm going to get rid of this. Throw this in a scrap heap. And like I said, that was a stator, and this is the rotor. It has magnets around the outside, and it's sitting on bearings and it spins, and pretty simple fan, but custom made just for this application. So here's one of the fan controllers, and this thing, like I said, it takes 350 volts and converts it into 235 three-phase, and it's a variable speed, I'm assuming. These fan controllers probably have a range of operation they work at. Let's just open this up and see what we can find inside. So the server I purchased was a government computer, and when I purchased it, it was stored outside in the elements, and it was missing the front and back cabinet doors. So essentially all it had was the cabinet top and the sides to shelter it from the weather. And I don't know if you can see this, but a lot of these components got wet. You can see there's water damage around these input connectors. And so this isn't something that you could take and put on the resale market. You wouldn't be able to trust it working. Oh, I still got one more screw here. So the case itself is heavy gauge steel, and it's perforated on all sides except for one. How this mounted was, there's two slots here, and that would go into two hooks, and then it would go up against a steel plate, and it would be secured down with these two screws, and the connector would be there for the fan. So this thing just mounted right on the fan housing. So I guess it would get a lot of its cooling from the fan it's driving. So here's the lid. It's got some insulation here for the high voltage area. So inside, well, let's actually open this up better. Let's see how it look inside. Pull this out. An insulating sheet and a steel case. This is very heavy duty gauge metal. It's not like the cheap Chinese stuff that we're used to on our PCs. This stuff is heavy duty. Just want to take a look at. Oh, I broke my caliper. Just want to see what this is. 1.3 millimeters. It's all steel. So before we go too far here, let's have a look. J02, J01, these are power inputs. You got two for redundancy. In case one power supply fails, it goes on to the other one. And this is the output three-phase connector to the fan. And it's got some feedback on there as well, because the fan, here's a printed circuit board from inside one of the fans. And I thought I saw Hall effect sensors on these. No, this one doesn't have any. Some of the fans had Hall sensors on them to sense the speed and everything, but this must have something, because there's quite a few wires here. So let's have a look at this circuit. They use top shelf components on everything they do here. There's no skimping on quality or quantity, for that matter. If they need something, they'll put it in. And when you look at server components, they jump through a lot of hoops just to accomplish something that can be done simply. But you know, they want to make sure that it's got redundancy and it's built to a spec. So let's remove these screws. that it? 3? Okay. We'll remove the heatsink in a bit. So you're going to see date codes all over these things, and they all point to 2008. This server was built in 2008, and 10th week. Here's another one. Date 2008, 21 week. Oh, here's another date code, 09 of 08. So pretty much everything points to middle of 2008 this thing was built. So this is like cutting edge computer technology from 2008. This is the best you could get, where no expense was spared on building. So if we look at the circuit, we have 2 power inputs, and you can see high voltage. They've made cuts in the board to provide better insulation from the pins so you don't get carbon tracking. There are 2 input powers, and along with the power connectors, they have data lines as well to send data back to the monitoring processor. 2 power inputs, and then they have a couple of blocking diodes here just to keep power from backfeeding into one from the other. There's a couple of diodes there on a copper heatsink. This is copper. I don't know if you can see the copper, but it's plated with nickel or something. Goes through from here, from the diodes, it goes straight into the fuse, and then it goes into this filtering network here to keep EFI down. There's a bank of capacitors. These capacitors are 10 microfarad at 450 volts, and there's 7 of them. And so a little bit of clean up the power there, just to make sure it's good. Got all these resistors wired in parallel. I wonder, it must be some kind of current limiting. There's a massive 10 microfarad 450 volt film capacitor, and then it goes into the inverter stage, or converter, whatever you want to call it. And let's open that up. But before, so it goes into this capacitor, 10 microfarad 450 volt DC, and from there it goes through these, I think these are current sharing resistors, and then it goes to each pair of transistors. There's like a 16 gauge wire run directly to each pair of transistors. Let's just remove these. Let's remove these and see. Okay, so now we can remove I expect these are probably just MOSFETs, and what they do is they just Probably not the right way to do it, but it's quick and efficient. You don't want to let go. Well, they will. Alright, so on the heatsink we have 3 modules, and each module comprises of a pair of transistors, or MOSFETs I guess. And these are attached down with heatsink compound, and these are copper plates. So these transistors solder directly to a copper plate. Well, actually no, they're soldered down to a copper trace, which is sitting on a copper plate. It's insulated and probably has capacitance too. But these transistors and MOSFETs, GSL15B60K, I'm gonna go look those up, and then I'll put a thing up on the page here. But this heatsink is cast and machined just for this purpose. So it's cast here, aluminum cast heatsink, and they machined it flat. And that's just enough to get the business done. Get airflow through there. And that's your cooling. So we had power going from this point to these 3 clusters of transistors, and on the other side there's not much to show. The transistors, and then from there the power goes directly to the plug, and then in between everything we have a processor here. It looks like an Altera Max 2 EPM 240T100 C3N, so the processor, and then there's some TTL logic here. This is a LM319 op amp. Some more support chips. Some of these I don't recognize at all. What does this say? LMV932? LMV9. I don't know what that is. So it looks like it has its own microcontroller, and that probably senses feedback from the fan, has fault detection in it, produces error codes, and generates alarms if things go wrong. This is all, see, we got some isolators here. It looks like this is all isolated with this, and that would explain maybe this little transformer here. And they got probably a little switch mode power supply going here. Little switch mode power supply to supply the power for the opto isolation, the feedback for the signals. So let's look at this again. We got 2 power outputs, isolated from each other from diodes, with diodes. Goes into a 400 volt 125 or sorry 12.5 amp fuse, and then it goes through power conditioning and filtering, and then there's this main filter cap here for the transistors. This is supplying the power to them. I suppose they do this because let's remove this cap. So this cap alone is a 10 microfarad, 10%, 450 volts. Let's measure it and see what it says. It comes out at 9.93 microfarads, and it has an ESR of 0.04 ohms, which is very, very low. So it's well within the 10%. It's actually probably 1%, and very low ESR. The reason they use this is because the ESR is so low. These caps here are the same value. Let's check one of these. The reason they don't just slap electrolytic on there is because the ESR on these is much, much worse, even though they're high quality capacitors. This is a 105C KXG Nippon Chemcon. Let's measure this one. This one comes out at 9.8 microfarads, and the ESR is 3.6 ohms. So you can see the ESR between the two of these is there's no comparison. So that's probably why they have one of these as the supply caps for the transistors. So we got some logic here, some data feedback, signals feedback to the main processor. What is this? This is a 5-volt regulator. I think this is another regulator here. National Semiconductor. That is a 78LB LM60. I don't know what that is. It's a 3-terminal device. It's got ports here for maybe troubleshooting and programming maybe. Everything's gold-plated connectors. The fan connectors gold-plated. Input power is gold-plated. Pretty much everything on this is top shelf. You don't get any garbage components on these, and they don't take any chances with using garbage components. So that's all this thing does, is it takes 350 volts in, converts it with these 6 transistors to 3-phase power. Variable speed, obviously, to keep the fan will be variable speed controlled, and variable frequency. And yeah, here's you can see the data lines here from the opto-isolators. There's some, they put tape over it to insulate it better. There's some data lines coming back, and they're buried in the board. So I don't know how many layers this board has. It has 1, 2, 3, 4, 5 layers, I think I can see here. Look at the attention to detail here. They have, for the high voltage, they have slots cut in the board to provide better insulation. And then here, this one pin gets insulated with a barrier. Let me pull this out. It's siliconed in so it doesn't fall out. Let's pull this card out of here. So the slot is cut, and then they jam a piece of insulating sheet in there, silicone it to hold it in place, and you know, that's how they get their insulation. Even here they have slots cut from the high voltage to the signal. Quality resistors here, some 15 ohms, 10%. I bet you these are 5 watt. Kind of a unique design. They have a channel in there. Is that for sliding onto mounting tabs maybe? Ceramic. These capacitors here are Y2, X2. These are line rated capacitors. Very high quality. So that's pretty much it. There's some interesting stuff in these components. These here, I'm going to go look these up. But they seem to be working in pairs for each phase. Each phase has 2 transistors, and they're probably working in like a Class B operation where they're push-pull. Or no, Class C is push-pull. I thought Class B was... Class B is with the cutoff, the crossover distortion. I guess they wouldn't care about that on running a fan. Nice heavy heatsink. Fully cast. Just for this application they cast this. Some of these aren't shelf stock parts. You got to make parts like this specific to your application. Yeah, I think that's a MOSFET there, and that runs this little DC to DC converter. So these are great for harvesting parts. If you need any surface mount components, some of these voltage regulators, there's an op amp here, there's transistors. I don't know if you're going to go into salvaging those, but you know, some of these surface mount diodes, they're very high quality diodes. I wouldn't be surprised if they're Schottkys or fast recovery. These high power resistors. These are probably 2 watt or 5 watt resistors, I'm guessing. Very interesting. All the caps are silicone down, so they don't move, and then they have the air, they space enough so the air can get through and keep these cool. And you got to imagine, you got to appreciate that this thing's probably been in service for 10 years, and look how clean it is. My hands are a little bit dirty, but look how clean it is. as far as dirt and dust goes. You know, they take the cleanliness of their computer rooms really serious. When you got equipment of this expense operating, you don't want it plugged up with dust and cause a malfunction or a breakdown. So they pay attention to that. Airflow on this probably came from the big fan itself. So I'll harvest a few parts off this, and then whatever I can't harvest will get put in for recycling scrap. It's very high quality. 20 amp diodes here. 20 amp 600 volts, I'll bet. And there's no garbage components in this. So there's a look at the simple fan controller. You see how complex they are just to control one motor. But this server had 4 of these, and there's controlling 4 different fans. And those 4 fans were the main cooling for the 8 processor slots. And I'll get to those in future videos. I'll get to the processors and the power supplies. But I wish I kept more of the server intact so I could have at least pictures of it to show you, but I didn't. I scrapped it out right away. The cabinet itself was huge, like I said. I took it, once I emptied it, I took it straight to the scrapyard, and it scaled in at, it was over 1,000 pounds, and I got paid for the iron and that. But you know, when this came in, I had no time to basically document any of it. I just had to get it moved and get it ripped apart, and time was of the essence. So yeah, but I'll have more videos of this stuff coming up. This is interesting. I find this interesting, even though it's a simple fan controller. You can see how complicated it is and how much attention to detail they put into it to make sure it works and it's reliable and it's you know, it's going to do the business. But yeah, I wish I had more pictures and video of what I purchased to show you. But I think you'll get the idea once I go through the teardown videos of all the rest of the components. I think you'll get the idea, the scope of the server itself, the size of it, and the scale. And you know, it looks like they go to no. They don't spare any expense here, even if they're going to roll their own heatsink like this. They go to a lot of trouble to get it right, and they don't rely on other manufacturers to do it for them. This is all manufactured in-house. Delta Electronics of Slovakia. It's copper plates. They probably rolled their own heat sinks too, even though there's no part tag on it. But yeah, pretty interesting. Alright, well, thanks for watching. Hope you enjoyed it. If you have any other comments, I'd like to hear from it, because I'd like to hear feedback from you guys. What do you think of this, showing this kind of equipment off?